Hello everyone, my name is Yang Xinlong, a master student in Peking University. Today I will give you our presentation, and the title of our paper is Prototypical Mixing and Retrieval-Based Refinement for Label-Resistant Image Retrieval. And this is the outline of this presentation. It is divided into 4 parts. Part 1, Introduction. We start by giving the problem definition of image retrieval with label-raising. Given the training set, we aim to learn a mapping to project data point into an embedding space, where similar imaging pairs should be mapped into similar deep features. As for label raising, in our setting, we assume that the observed labels could be wrong. There are 2 challenges in this task. The first one is ear-nose supervision. Extensive label raising could result in near-nose supervision information during the model training stage. And the second one is serious memorization. The overfitting of low data would compromise the optimization process gradually. Part 2, methods. We name our method Titan, and this is an overview of our proposed Titan. It firstly estimates the distribution of prototypes for each class, from which we sample features from mixing to generate virtual features. Moreover, Titan retrieves different samples for every prototype to refine noisy samples, and the final noises are composed of both similarity learning noise and the clustering noise. The first model, prototypical mixing. We characterize the distribution of each class as a latent Gaussian distribution so equal 1. Then, for each sample, we select a prototype with the maximum probability. Finally, we randomly generate a feature from corresponding Gaussian distribution, and the mixed hidden feature can be written so equal 3. Through prototypical mixing, we extend the ERM principle to the VRM principle. In this way, our Titan has a strong capacity for generation and is resistant to the memorization of noisy samples. The second model is retrieval-based refinement. Specifically, we review the central of each prototype as a query and retrieve key samples in a dataset based on the Euclidean distance. Moreover, following principle of concurrent learning, we propose to increase the retrieval number k gradually. Part 3, experiments. Table 1 and Table 2 shows the MAP scores on kinetic noisy benchmark, and Table 3 shows the MAP scores on real-world noisy benchmarks. In both settings, our method achieves the best performance. Figure 3 and Figure 4 shows the PR curves and noise rate curves respectively. Even in high noise rate, Titan still shows strong performance. Figure 5 shows the MAP of corresponding to a different hidden dim. Probably because of the error normalization, the MAP value does not change much with the increase of hidden dimension. Application results validate the effectiveness of our different models and designs. And the sensitivity analysis shows that our proposed Titan is not sensitive to these hyperparameters. Conclusion. We study a practical but less exploited problem of label-resistant image retrieval and propose a novel method to solve it. In future works, we would extend our Titan to more settings such as learning to harsh and cross-model retrieval. Thanks for your listening.